Hi, my name is Harish, and this small screencast I'll be showcasing my approach to graded assignment 8 of Introduction to Big Data course. So the objective of this assignment is to basically uh, run this uh, decision tree model, train a decision tree model on the immense data set. So, so this here what we have to do is that you have to train the decision tree classifier on the data set using PySpark. In this particular link, it was using Scala, but we have to do it using PySpark, and then we have to perform hyperparameter tuning using CrossValidator, and whatever the best result we get, we have to retrain the model again on that uh, parameters. After that, we have to save the trained model into a GCS bucket. Uh, Yeah, this is the first part of the assignment. So then the second part is to create a cloud trigger, a cloud function trigger, which when we upload a test CSV file to a bucket, that function should basically submit a PySpark job on the Dataproc. Uh, Load the saved model, which was done from the before part of the first part of the assignment, and then we test whatever the CSV file that we have uploaded. We take that data and test it on the saved model. Yeah. So and run the predictions on the updated test file. So this is what we have to do. So my approach is first, let me quickly show you all the uh, buckets. So I have created two buckets. One is IBD GA8. This will basically have all the output file. Mm, so yeah, the output file will be the model. I will delete it for now. This was from my last run. And the predictions will basically have the predict of final prediction. Uh, so this is also from my previous run. Yeah, so these two I'll delete it. So the input already has the input data, that is the test and train of MNIST data set. I have uploaded it in the input of the same bucket. Now I have another bucket called IBD input tests. What this will do is this is where the trigger will be set. So whenever we upload, I will remove this as well. Whenever we upload this test file, oh, this bucket, anything we whenever we upload anything into this bucket, that will trigger the trigger function and generate the data prop job. So this bucket will do that. All right. So this is the bucket setup. Now moving on to the first part of the assignment, I have done it in. So I have already created the cluster as well. Let me quickly show you that. Yeah. So this is the cluster that we'll be using. IBD week 9. So in this, I have already SSH'd into this. As you can see, it is already running, and I have it open here as well. So this is the Jupyter notebook. Let me quickly open it and clear previous output. Yeah, this is not running right now. I will quickly run all the cells because it will take a lot of time to train the model. So I will run it while I explain it. So yeah, so this is the initial part, all the import statement, the Spark is running. Then we load the training and test dataset from the bucket. So as I just showed, the IBD GA8 bucket has an inputs folder inside which both the train and test file is there. So these are in the libsvm format. I can actually show you that as well. Um, uh, Here, as we can see, mm, Yeah, so this is, let me just show you the train. Yeah, so this is in the uh, format, uh, yeah, lib SVM format, and we parse it using the Spark library, and we load both the train and test files. As you can see, this is how it is, the top 5 rows, and then we build the pipeline. Uh, so we first do the decision tree classifier, we perform the classifier and build the pipeline. Basically, the param grid has, we do the max depth, max bins, and the instance per node. Then we perform the cross validator. So this is the pipeline. Uh, we perform the classific decision tree classification. Then we do the param grid and then we perform the cross validator. So yeah, so this is right now running. Once we complete the run mm, of the cross validator, we print the best hyperparameter and then we evaluate it on the test data. When we find the best model, once we have the best model, we retrain with the best hyperparameter values again, the decision tree classifier, and then we print it and then we save it to the GCS bucket. So this will be saved in the IBD GA8 buckets output folder with this particular name, means GT final. So this is where the best model will be saved. So yeah, so this will take some time to run. In the meantime, I will explain the second part of the assignment as well. Um, all right, so the second part is to create a trigger. So let me quickly show you my all the cloud runs, mm, cloud run functions. Yeah, so I've already created the run function. It's called GA8 run. So what it has is the yeah, I've already set up the trigger as well. So as you can see, the trigger is to receive events from the input test bucket, IBDG. See, this is the second bucket, and whenever this particular event type, event provide, whenever it is the storage, basically, whenever we upload anything to this particular bucket, this trigger will be active. Then the source code is, so this is the source code. It is the same project and the cluster. We are using the cluster that I just showed before, IBD week 9 GA. The model path is this one, whatever the notebook saves. Then the predict script. So this is the predict script. I will explain that as well. The output bucket. Output will be stored into IBDGA/predictions. That is where the output will be stored. And the hello GCS, the main function, what it does is all the safety checks are basically to prevent looping. So in case if it is not a CSV file, then it will ignore. If it is temporary files, like so in my one of my initial runs, a problem I faced was I did not particularly specify where to save the output. So it's saved in the very same bucket itself, wherever the trigger is set up. So it just went on a loop, creating multiple runs, multiple jobs, and then failing that job because it was not a CSV file. So just to avoid that. So this is actually not required, but still just to avoid it because in the later revised version, I separated both the buckets. So all the input output saved, all the saving part is done in the first bucket, that is IBD GA8. So this bucket will deal with all that. The trigger is set up in the second bucket, that is this one. So this bucket will only act as the trigger. So I upload the CSV file here, and then it acts as the all the other things are done in the other bucket, second bucket. Okay. So moving on, so what the next part is, this is the file path. So it will print the log processing new CSV upload. Then it will create the job. So the Dataproc job will be created. In the job, it will pass the predict script. The predict script is basically in my GA8 bucket. So this bucket has code slash predict.py. So this py is what will be run in this Dataproc job in that cluster we created. It submit the job, and once the job is complete, it prints Dataproc job submitted successfully. So basically, what this is doing is whenever there is any file upload on the input this bucket, that is input test bucket, it will run the predict.py file which is present in this uh, code slash predict.py. Okay, before I explain that, let me just quickly check whether this is done. Yes, so this is done. So the model has been created. The best max depth is 10 bins, 32 minimum is 1. And then it is evaluate accuracy is around 79-80% accuracy. Then we retrain it with the best hyperparameters. Retrained accuracy is also similar. And then we save it to the GCS bucket. Now let's just quickly check whether it has been saved or not. So it should save in slash outputs. Yeah, so that has been created. We have a timestamp. I think we can see the timestamp here. Yeah, just now it was created a minute. Just now, when the job was complete, when the notebook ran. So this happened just now. All right, so that is the first part complete. So the model has been saved to the bucket. So this much is complete. This much is done. Now the second part. So the trigger function is already set, like I explained. So this is the trigger and the main.py setup to run the predict.py file. So this is the cloud run function. Uh, Now let me show you the predict.py. I think I have it locally as well. Let me just explain it. Yeah, there it is. So what this is doing is it the model path, CSV path, and output buckets path will be passed to it from the cloud run itself. So if we see the cloud run, we have all that here. Model path, predict script, all the paths are there, and it is being passed as arguments. As you can see, it will be passed as argument, and this will be taken here as well, here in the predict.py as arguments. So we print that, and then we load the model from the model path. So the model path, the model that has been just uploaded, created from the notebook run, we load it, and then we load the CSV. So CSV is basically whatever gets uploaded, and then into the second bucket. So we convert the CSV into desired output into the vector, and then we perform the predict model.transform, give the prediction, and then we create a output. So the output path is basically output bucket slash CSV underscore predict. So this is the output path, output bucket, whatever the output bucket is. Output bucket is slash prediction, IBD8 slash prediction. This is the output bucket. In the bucket, mm, this file will be created. CSV name underscore predict is where all the output CSV file will be saved with the predicted values. So I will show you this once we run it. Then we'll also get a log called save prediction to this particular path, and then the Spark will stop. So this is the predict.py. Simple. Just to in a nutshell, it loads the model, loads the CSV file, and then it performs the prediction after converting it into desired vector, and then it saves the output. Yeah. So this is the py file. Now let's see. So I will open the logs here, and then this is our, yeah. Here I have to upload the CSV file. All right, the CSV file is present here. If I just show you the file, I'll show you the content of the file as well. But let me just show you. Yeah, so this is the CSV file. Basically, it has all the values. Uh, yeah, as a CSV. Minced data as a CSV. So let me upload it. So I think I will just drag it. Yeah, so it has been uploaded. Now, if we quickly see the, yeah, so this is the latest. Okay, this is the old one. I think I have to refresh it. Okay, I think I know what will happen. Since this is already running, it will not have enough nodes to perform it. So I will quickly stop the notebook. Otherwise, it will not run. Yeah, processing new. So this is uh, uploaded right now. Processing new CSV upload. Dataproc job submitted successfully. So the job has been submitted. Now, if I go to jobs, where is it? Yeah, cluster and jobs. So the job has been submitted. From the trigger. The Cloud Run function ran and the job was submitted. Yeah, so this is the latest job at 9:48. I hope it ran. I hope I will not. Yeah, it ran. So as you can see, these are the model path, CSV output bucket path. Then the predictions happened, and it saved it into IBD slash prediction slash mints test. So it saved directly into this particular the prediction was saved into the bucket itself after running the model. I mean, after loading the model, running the CSV data of the CSV into the model, it saved it into the prediction file. Now, if we quickly see this is the prediction file should be created here. Folder prediction directly should be created here. Yeah, so this is the prediction directory. And if you can see, the time is at 9:48. So as soon as this matches with the cloud runtime. Let me just show you content of it as well. Save it, open it. Yeah, so this is the one JSON file. So this is the data followed by the prediction. So as you can see, the prediction is basically this one. So the data, whatever the data is present, followed by the prediction is 5. Then some other metadata. Then the next image followed by the prediction of 0. Now to confirm this, whether this is the correct prediction, I had actually created a script which basically shows us the data. So I have a script to view the data. So this image, I will delete it. So this will, what it does is, this is a simple Python script. It loads the CSV file that we uploaded. So this is the test CSV file that we uploaded. So this Python file basically loads that CSV file and then it creates the images of the data that is present in that file. So very simple. Now this is the one. This is from the last run. Right now I have deleted the data. I've deleted all these images. I will run it again. So it is view means CSV file. Yeah, all the nine rows are there in that file. Now, if you see the images, yeah, we can see the image zero, first one. This is the first image. It is basically five, then zero, four, one, nine, so on. Now let's verify with the output that we got. Yeah, so this is the output that we got. The first prediction is five. Yeah, 50419. Now let's see. The second prediction is zero. Third prediction is four. Yeah, here. The uh, fifth prediction is four as well. Okay, so there is some error, but since it is 60% accuracy, we will have the next is nine. Prediction of nine, right? Yeah. So prediction of nine. So there is some. So this one there was an error, but yeah, 5049 and one error. So since the model accuracy is 80%, we can expect some errors. But yeah, all in all, the cloud function ran and the prediction happened as well. So I think that covers the second part of the assignment as well. That is, create a cloud function which triggers when the CSV file was uploaded. Then it submitted the PySpark job on the Dataproc cluster. So we can the ECS path and the test CSV with 10 rows and the data pro it loaded loaded the saved ML model from the GCS, ran the predictions on that particular file, and then it logged. It basically I did not log it, just I only logged the all the these I did not log the exact outputs. I only saved the output into the bucket. Instead, I just logged all the, as you can see in the job, if you open the job, yeah, I only logged the paths and the saved. Once the prediction is saved, the output is complete path. That's all I logged. I did not log each and every final values. But yeah, you can, as I already verified, the model ran as well, and the prediction also happened. From the JSON file we downloaded, we verified that as well. So I think that concludes the assignment. Uh, few mistakes I came across when I performed these are again infinite job submission happened. I think I already explained it because I did not specify the parts of the output and the two buckets. So the output prediction happened in the same bucket as the trigger function was present. So that created infinite jobs, infinite runs. Then I had to I solved it by separating the output into the first bucket and not in the trigger wherever the trigger function is there. Then there were other syntactical errors, but those were solved. Nothing major to discuss. Yeah, so this was a very a little hectic, big assignment. It took a while to run. But it was few things I learned from the assignment, especially how to run the PySpark ML pipeline on the Dataproc, cross-validating and hyperparameter tuning. Then how the Spark models can be saved and loaded from GCS, how to use cloud functions to automate pipelines. Design event-driven systems, have handle Spark vectorization in PySpark and also debugging everything. So yeah, these are something things I learned. Also, I had created a quick uh, mermaid chart of the actions. First, the upload, then the cloud storage trigger happened, and then the train model, which was already present, and the Spark script. All these acted. So these first the trigger upload happens, then the trigger happens, and then the trained model is loaded, and the PySpark script is ran. That will create the job, submit the job in the Dataproc cluster, and then it will predict. Once the prediction happens, it will write the prediction into our predictions folder. So this is basically what this assignment did. Thank you.